Hi, welcome. Last time we created a simple model to plot a sine wave. In this video, we'll develop 3 models for a spring mass damper plant. For the first model, we'll use general blocks such as gains, integrators, and a summation block. For the second model, we will use an LTI block with a transfer function. Similarly, for the third, an LTI block will be used with a state space model. I'll start pysimCoder from the tutorials folder. By doing it this way, it handles the directory folder location. I'll save the file and bring our blocks for the first model. Next, we can wire the diagram and rename any blocks if necessary. Now we can update each block with the appropriate values. Now we can save and run the simulation. We can change the final simulation time, perhaps to 5. That concludes the first part, where we use general blocks to develop our model. Before we move on to the transfer function, we can create a subsystem. When we double-click on a subsystem, the diagram opens and we can make changes. For the transfer function, we bring an OTI block. Note that pysimCoder can also handle discrete time. To configure the LTI block, we can double-click the block. We see it's already configured for transfer function. Now we can update the values. We can wire the input, and we can add a second input to the plot. We can save the model and run a simulation. We do see a difference in the results. We can improve this by decreasing the sampling time. A very powerful feature of pysimCoder is the ability to link a Python script to a block diagram. To showcase this, I'll create a simple Python script and link to this model. To link this Python script, we can go in pysimCoder, Settings, Parameter Script, and select from the list. We can now use information from the Python script inside pysimCoder. We can even define our model, either a transfer function or a state space, inside the Python script and pass that model to an LTI block in pysimCoder. For the third model, state space, let's use the Python script and link to a new LTI block. We can also change the initial conditions. As we're wrapping up this video, I want to show you 2 more ways to perform a simulation in pysimCoder. First, I'll simplify the model. Then, I'll replace the plot block with an RTPlot block. The RTPlot block gives us new options here. We'll keep it as 1 for time-based. And we will run a simulation. Now we get a moving plot. Note that this is not in real time. Now I will change the template make file from simulation to real time. We won't be able to run the simulation as is because we have a different template make file. But we can generate code. New files are generated. We can run this file from the terminal window. You can notice that this is not running in real time. This computer doesn't have a real-time kernel. Later on, we'll be running simulations using one of our targets, and that will be in real time. To run a simulation for a specific amount of time, we can add f and the amount of time we want to run, for example, for 5 seconds.